In this video, we are going to move towards defining the Riemann integral, but we'll need to develop some other ideas first. So the first thing that we'll look at is a partition and then a refinement of that partition. So a partition P of a closed interval a to b, it is a finite set of points, x0, x1, x2, up to xn. So the total number of points that we have here are n plus 1 points. So x0 and then the other n points. And so we have these points such that our first point is that value a from our closed interval. And then the second point, or the final point, is that value of b. And so we have this set of points. We can then, so we have this partition. We can then refine that partition. We can get a refinement of that partition. So if P and Q are both partitions, Q is a refinement of P if all of the points in P are also contained in Q. Right? So if Q is a superset of P. All right, so let's look at a quick, simple example. Let's say that we are considering some partitions of, let's say, a closed interval from 1 to 4. And so one partition that you might have is P is equal to the set 1, 2, 3, 4. That is a partition of that set. Notice that our first value here and the final value here, they match up with those two values. We could also have another partition. Let's say it's Q, and maybe Q, maybe this Q has the point 1, has 1.3, has 2 and 3, maybe 3.7 and 4. Then Q is also a partition of 1, 4. Notice again that the first point is that value 1, and then that final point is the value 4. And also notice that we have P is fully contained in Q. Everything in P is an element of Q. All right, so 1 is there, 2 is there, and 3 is there, and 4 is there. So we would say that P Q is a refinement of P. So it takes P and it refines it. It throws in some extra stuff. All right. In the next video, we will look at upper and lower sums and start to build this idea of a Riemann integral.